first off, I messaged you a while back and said this will show up in your future. I could see it. I've seen the future, and your future holds this question, possibly in an exam, maybe, I don't know, but we want to prove that the line passing through these arbitrary 2 points, x1, y1, x2, y2, can be written as this. And it's in lecture 3.1 supplemental. If you basically, what I'm saying is, if you just do exactly what I did in lecture 3.1, then that is what I'm looking for. So what I want, but my whole point with this is that you can do it on your own. Like basically, if you can just reproduce on paper what I have done in lecture 3.1, then this will, it's not this formula is not the point, but the method will be lodged in your brain. And that's basically, if that's in your brain and you could call that up at any time, you're going to be leaps and bounds ahead of most people. Like this is a big takeaway thing. And I really want to, so it's not simply that you're memorizing my argument. It's that you've gone over the argument enough times that you could reproduce it so that it's really locked in there. Does that make sense?
Yes.
So I'm going to be looking for, like, when I give you, or in the future, when this problem shows up, I'll be looking for pretty much exactly what I've done, which is, and I want to make a point that you do draw out the 2 points, just like I do. And you can draw them out any way you want, but I mean, that's where you should start, is drawing out the 2 points and then explaining, like, this is the rise and this is the run. That's how I get this, and then going from there. But so I just wanted to remind you of that, and it's all in lecture 3.1 online. The second thing is, I mentioned, I think last week or 2 weeks ago or whatever, I would like you to redo number 54. And I think we lost sight of that.
Ooh.
So
I completely forgot all about that.
Yeah, I know, right? And so in particular, I want you to answer these 4 questions. And so, or do these 4 things. So first off, if you remember, I said that, remember, this question gave 2 data points, that at this year, the land speed record was this, at this year, the land speed record was this, and then we model that. That's what it's called in science and applied mathematics, is that we make a model to describe this behavior. And I want that model. I want to see what it is. I want y equals some number, x plus some number. And like I said before, you could use a calculator and round m and b, but I want, that is part 1, right? I want to know what that is. Then part 2, use that model to predict what the land speed record will be in 2008. And that's pretty much what 54 was asking. Now I want you to go a little bit above and beyond. I want you to use your model, that is that equation. I want you to use that model to find the land speed record in 1054. And yes, that's the year of the Great Schism, right? Like 1054. And then from there, I want you to, a little bit of critical thinking. Are the results from number 2 and number 3 reasonable? Explain. Finally, what happened? You'll see what I mean when you do this. You get something's going to happen, and you're going to go, And then I just want, in your own words, I just want you to describe it. That's not really, you're not going to be graded on this explain what happened part. I just want to see what's going on in your brain. And we will talk about it once you turn it in, because it's very important stuff. In fact, if there's like 1 or 2 things that you take from Algebra 2, it's what we're going to talk about here with this problem. So, are we good to go? Okay, cool. I'm going to erase this. We are going to get on to our topic for today, which is more factoring. Okay, so I am not, I've said it 1,000 times, I'll say it again, I am not a proponent of memorizing things. I hate memorizing things. However, there are like a handful of things that I have just locked in up here in this brain. These are some of them, and I will recommend that you memorize these things. And the point of this, I just want to be clear, the point of memorizing an equation or a formula is not to plug it in and stuff like that, like, or to know when do I use this in what situation. We're gonna, it's, well, it is to know when to use it in what situation, but it's not simply like, I don't want us to have the idea that there is a formula that works in such and such a scenario. That's not what we're doing here. I want us to memorize this simply because it's going to be useful. It's going to be very useful in the future, and especially on this homework. Oh, he opened up the, great. Well, this is going to get messy. But okay, so first off, here we go. We have, and we saw this last time. This is the difference of two squares. A squared minus b squared is equal to a plus b and a minus b. We talked about that last time. If you first outer inner last that guy, you can verify that this does work out to that. Now, here's another one. We have the difference. Actually, let's do the sum first. We'll do the sum of two cubes. That is, so we have the difference of two squares, and now we have the sum of two cubes, and that works out to be a plus b times a squared, ab, b squared. You'll notice how I wrote that. I didn't write out the pluses or the minuses first, and you will see why in just a second. And so we have that right there. That's what it turns out to be. And again, if you wanted to, you could verify that this works by just multiplying everybody through, right? And then adding them together. You'll see that you get this. Oops, oops, oops. I did the stupid thing. Yeah, it's your shoe. That's right. Thanks. Then we have the difference of two cubes. A squared, AB, B squared, a plus and a plus in that case. I got it right this time. Sorry about that. So these are the basically three things that need to be so deep in your mind that you could just whip them out at any time. However, there's a nifty little mnemonic device to use to get these guys. I'm going to demonstrate that right now. So, and this is how I do it. In fact, like, and the reason why I messed this up is because I didn't do this the way that I normally do it. So what I'm going to recommend is that what I'm about to do on the board, I'm about to go through something and reason through something and say a bunch of things. I would recommend that you do this over and over again. Like in fact, we're just going to go ahead and say, this is going to be part of your homework. Like that you do what I'm about to do and think what I'm about to think or say, right? You know, that like, if you say it, I'm telling you, it makes it 10 times easier to remember this stuff. But go through and do what I'm doing and do this a few times until you could just do it on your own. Like until you don't need to look back on your notes when you could just do what I'm about to do. So yeah, that's, you took that off. That's right. So, okay. So we have a sum and a difference of two cubes. This is what I do. You say, oh yeah, the sum and the difference of two cubes. So I'm going to write the sum of two cubes right here. I'm going to write the difference of two cubes right here. And then there's this nifty little pattern. So I'm going to do a small parentheses and a little bit larger of a parentheses. Small parentheses, larger parentheses. And then, okay, whatever this guy is and whatever that guy is, he's an X and a Y. So I'm going to go, okay, there's an X and a Y. Then it's descending powers, right? And you'll notice, like, I've already written this up here, right? But you'll notice that this first part, the first parentheses, both of those are to the first power. And so we'd say that this polynomial right here has degree 1. And then you'll notice this polynomial right here has degree 2. In fact, every term has degree 2, right? That's a squared. That's a, which is to the 1, and b to the 1 together, they're 2. There is b squared. And so each one of those have that. And it's, again, like we like to write it in descending powers. So the x gets squared, then the x is to the first power, then the y shows up, then there's no x's, and it's y squared. The exact same thing I'm going to write down here. I have my x, I have my y, I have x squared, xy, y squared. You can see thus far, everything matches up right here. I believe I did that right. Okay. Now, this is the nifty little mnemonic device. I'm not sure if you've ever seen this before. If you've never seen sums and differences of cubes, you probably haven't. But so see where I wrote it? We have 1, 2, 3 missing places where we need signs. And I've written them where all of these signs show up. So stands for same, opposite, then always positive. So when I'm looking at this and I'm putting this picture together, because as far as I'm concerned, I'm not really thinking about math at this point. I'm just thinking about a picture. Like, anyway, that's how it is in my head. I'm thinking, okay, the only thing that's missing now are my signs. And so for this one, it's the same sign as what we began with. And since there's a plus there, I'm going to put a plus. Then it's the opposite sign. Since that's a plus, this is a minus. Then I don't need to use my brain. That one is always positive.
Oh,
Ditto down here. We have the same sign. And so since that sign is a minus sign, this sign has to be a minus sign. This is the opposite sign. Since this was a minus, this has to be a positive because that's the opposite. Finally, always positive is always positive. And so it's always plus. And so you can see, because I didn't set it up and do it this way, when I actually wrote this out, I screwed it up earlier, right? So this is a very nifty way. If you could do what I just did, if you could write all of this out, right? Starting with the x cubed plus y cubed, x cubed minus y cubed equals, and then fill in your stuff, and then finally fill in the signs, then this is locked in your brain, and it'll start to, then you'll get to a point where you don't have to write it down every time. It'll just be in there. And you, if you're like me, you could just see this in your head. And unless you're talking and recording something and trying to write on a whiteboard, 9 times out of 10, you could just pull it out and write it up the first time. But so, okay, does this make sense?
yes.
Okay, so real quick, I mean, we could verify this if we wanted to. I guess let's just do it with one of them. Because I don't like to just, again, I hate having formulas. I want to, whenever I'm given a formula like this, I like to verify it because it really solidifies everything in my mind. So what I'm going to do is say, okay, let's multiply this out. And the way I like to do it, right, I'm going to distribute my x in first. And so that gives me x times x squared is x cubed minus x times xy gives me an x squared y. X times y squared is plus xy squared. Okay, that's the first part. Now with the y's, the y hits the x squared, and I get x squared y. I'm going to write it as x squared y because that's how we do. So x squared y, and it's plus x squared y. Okay, the y jumps over and hits this, and it's an x y squared, but it's a minus xy squared, so minus xy squared. Finally, y and y squared gives me a plus y cubed. Now when I add all these guys up, it's easy because I went ahead and did the hard part by putting one beneath the other and lined them up the right way. Now the x cubed is just x cubed. These guys cancel, that cancels, and I'm left with plus y cubed. And so I could see, like, yes, this formula actually does work, right? I can see why it works, and I like that, verified that. If you want, go ahead and do it with this one too. So, okay, you ready to roll? Make sense?
Yes.
Good to go. Okay, so now let's apply this to something. Okay, so right away, actually, let's do one thing. That looks good. Oh, I like this one. So yeah, minus 8x cubed plus 27y cubed. Here's the problem, is that does not look like any of these, right? None of these have a negative in front of them. What are we going to do? What would you like to do to turn this into something that we've seen before?
Could you multiply them both by -1?
We could. The problem with that is we don't have an equation right now. If we had an equation, we could do that. But what I'm going to do, another thing we could do, because like what you're thinking is we need a minus sign right there. I'm assuming that's what you were thinking, right? It's like if that were positive and that were negative, right? In other words, multiply by -1, then we would have something that we've seen before. And then we'd be able to start a nifty little formula. But that's not going to work in this case because we don't have a thing. But there is something we could do. And I'll just go ahead and come to the point here. Is I can just rewrite it like this. That's why I wanted to do this one, because it's deceptively tricky. Like, this is the same thing as that. I've just rewritten it. And so that's going to be my first step. I'm given something that I haven't seen before. And math is like, I think of math as the game of turning things you haven't seen before into things you've seen before. And you're absolutely right. Like, if we had multiplied by -1, then yeah, we would have, this would have turned it into a minus right there and everything.
Pause it.
It would have actually changed the number itself. And we don't want to do that. So now, is this a difference of 2 cubes?
Yes.
Yeah, why? Because what is 27?
3 cubed.
3 cubed, right? And I was saying it's going to be really helpful to remember what 2, 3, 4, and 5 cubed are, because when you see something like this, you can immediately identify, hey, 27 is just 3 cubed. And so if we wanted to, we could rewrite this and say, you just told me 27 was what, 3 cubed? 3 cubed times y cubed minus, and what is 8?
2 cubed.
2 cubed, right? So we could say, well, that's the same thing as 2 cubed x cubed. And in fact, I'm taking this extra step here, but what I would have done is just rewritten this immediately as 3y cubed minus 2x cubed, like that. And I think that works. Yeah, if I had 2x cubed, it would be the same as 2x times 2x times 2x. Those 2's would all come together like that. Those x's would all come together like that. And I would have 8x cubed. And so, yeah, I feel confident about that. I haven't changed that. It's still the same thing. Okay. Ditto with the 3y cubed. But now I'm going to go ahead and rewrite this over here because I'm running out of some room. So let's have a bit more room here. I'm going to say, okay, so this is the same thing as 3y cubed minus 2x cubed. Oh, hey, look at that. That's lined up perfectly, actually. Now I'm going to see how we could use this formula. Okay, so I see that I have a difference of 2 cubes, and then that word pops into my head. Oh, difference of 2 cubes. There's a formula for that. And so I'm going to set it up the way that I like to, just like this. And I know, okay, it's whatever this is, and then whatever that is. And so right here, I'm going to go, I guess, 3y minus 2x in here. That sound right? Something like that. Okay. Now, how about this? Right. So in this case, what I'm going to do is I know that the first thing gets squared, and then it's the first thing times the second thing, and then it's the last thing squared. In fact, what I'm going to do, and this is how I would actually do this, is I'm going to start with parentheses and say, okay, it's the first thing squared, then it's the first thing times the second thing. Finally, it's the last thing squared, and that's how I would start this guy right here. Okay, so what's the first thing? What goes in here?
3y.
3y. And then what goes right here?
3y.
3y again, yep. Okay, what's the next part?
2x.
And then the last part?
2x.
Okay. Okay, now what about the signs? What should this sign be?
Plus. No, wait, no. Yes.
Yes, yes. And so in this case, actually, the way I would have done this is I would have started like this, and then I would probably just go ahead and do this and say, okay, wait. Same sign, same as that. So it's the same sign as that. That is a minus. Opposite right here is the opposite of that. So it's a plus, just like you said. And now what's the last?
Plus.
Always positive, always positive, always positive. So yes, plus, or always plus. That it also works. So always plus. So, okay, we got that. Now let's go ahead and make this look a little bit nicer because we're done technically, right? But it might be nice to go ahead and write these guys out. So how could I rewrite 3y squared? I'm sorry, yeah. How can I write 3y quantity squared? What is that?
Would you just take away the parentheses?
Yeah, but then what would I have? So remember, what is?
Oh, you'd have. Hold on, wait. 9y.
9y
Squared.
squared. There you go. So there's 9y squared. Okay. What about the middle part? What does that work out to?
6yx.
Where did that go?
And notice this is, and Usually, right, we do we write the x's before the y's. And if you did that here, you'd be absolutely
right.
It's just that the way we've written this, right, we have descending powers of y and ascending powers of x. And so it's a nice convention to say, well, then since the y is here, I'll put it on that same side as that guy. And the x is going to be over here, so I'll put him on the same side as that. So anyway, okay. Finally, then what do we have here at the end? What is the quantity 2x squared?
4x squared.
4x squared. And I think we are done. Although maybe not. Maybe this could break down some more. Let's see. This almost looks like a perfect square. I don't know. I have not worked this one out yet. So let's see. Let's just watch my reasoning here. So we have this. This can't be broken down anymore. We have terms to the first power. But now I'm wondering, is this thing a perfect square? Because I noticed that 9y squared is the same thing as 3y squared, right? I mean, that's it, right? This is also a perfect square. But actually, then when I go, I kind of stop and look, I could see like, no, that doesn't really look like 2 times something, but maybe I'll just check. Because if it is a square of some sort, or maybe if I can break it down, that 9y squared could have come from 3y and 3y. Yeah. Then this 4x squared could have come from a 2x and a 2x. But now when I go inner outer, I'm going to have 3 times 2, which is 6xy, another 3 and a 2, which is 6xy, and that's not going to work. And so now I could have actually, I could just kind of see because of where this came from that it's not going to break into 1. But I am in the habit, and I think it's a good habit to get into, to just check, just try and see if you could continue factoring. Because in your book, and whenever I say factor, they mean factor completely. And so just looking at this, like I said, I hadn't worked this one out before. I wasn't 100% sure that it couldn't be broken down more. So I'm going to at least try. And now that I can see like, nah, this ain't going to work. That's not going to break into some kind of perfect square or anything. Now I could say, okay, then we're done. That is completely factored. And that's my answer right there. So they will be tricky with that. They will give you ones that will break down and you think you're done right here. But then if you look and go, uh-oh, that actually factors even more. So you got to be careful with that. So good to go on this one.
Yeah.
Okay, cool. So, all right. Factor, and we're just going to factor. And now, yeah, we're basically, and then for the rest of this, so in your homework, you're going to have some sums and differences of cubes. And that it's pretty much, I mean, don't think about it as plugging it into the formula, but that's basically what you're doing. You're going to use this right here. And then, of course, every time that you get down to this point, you may not be done. Like in the last case, we happened to be done. There was no way to factor it more. But the ones that they give you in here, they might factor even more. So you got to be careful with that. Now, then the majority of what you're going to be doing for the rest of the homework, and pretty much whenever you factor things, is unfoiling, basically. And we talked about this last time. So let's do a couple examples. So we have that right here. Okay, so let's say we are given 10x squared plus 23x plus 12. Okay, so I look at this and I'm told to factor this. The first thing that goes through my head is there a common factor that I could pull out? And that's pretty much going to be my first question with any factoring problem that I'm given. Is there something that I could pull out? And I notice, okay, 10, and this is kind of what goes through my head is, well, 10 is 2 times 5. 23, actually, that's a lie. The first thing that goes through my head is I look at the variable and I see, okay, there's an x squared and then an x, and then there's no x's. So we don't have a common factor that I could pull out because this guy doesn't have any x's. So, okay, x's, no help there. 2 times 5 is 10. So now I'm looking at the numbers and seeing 23, I believe, is a prime number. 23 is prime, right?
I think so.
Should be, right? We'll go with that. So 23 is just 23. 12 is 2 times 6, which is 2 times 3. So 2 times 2 times 3. And I don't have anything common. I have a 2 and a 2 here, but that 23, that prime number is messing me up. So, okay. Question number 1, is there a common factor? No, there's not. Okay. So 2. Then we are going to, what? And this seems silly. But given a degree 2 polynomial, right? Something squared, something to the first power, something to the 0th power. We're thinking, oh, okay, so you took 2 things and you foiled them together. And so right now I know that my job is to unfoil this thing that was foiled together. And so my first step then, or my second step now, is going to be to write this like this. I like this in the same way that I stress over and over again. When you're looking for the equation of a line, go ahead and write this somewhere on your page so you don't lose sight of the goal. Right? This is the same principle at play. I know that this came from this type of thing. There was a first, an outer, an inner, and a last multiplication that combined somehow to give me that. So I'm going to write that so that it's like now I've just realized that, which is to say I've just made that real. That is much more real in my head now, what we're doing. So step 2 seems stupid, but there's an actual reason for it. So we're writing that down. Step 3. Find your F, right? And F, I mean, we're thinking about FOIL, right? First, outer, inner, last. We know that the first thing must have come from this. So what possibilities do we have for what can go right here?
Well, it has to have an X, right?
Right, we need to, I know that there has to be an X in each one. There's no question about that. Okay, so now, but we do have possibilities because we said 10 can be written in a couple of different ways, right? 10 is equal to what?
1 times 10 or 2 times 5.
2 times 10 or 2 times 5. So which one do you want to try first? No wrong answer. Which one do you
2 times 5?
2 and 5. I like that one. That's what I'm going to do. So I'm going to go ahead and write it down. And so this is everything we're doing right now is involved in step 3. We're trying to find F, and we're doing the different possibilities. We know that there's 2 possibilities for what this could be. And every step along the way, I'm going to, once I write something down, I'm going to stop and make sure that if I were to then FOIL this out, that I would indeed get what I have. So for instance, when I given this, if I said, okay, do first outer inner last. When I do first, I get 2x times 5x. That does indeed come out to 10x squared. And so, okay, I feel good. All right, so we're going to try that. Now, we might have to go back to part 3 if we figure this out wrong, but as of right now, part 3 is done. So now part 4. We are going to find L. That's L. It's the last. Okay, so again, I'm thinking you've just FOILed something out. You did first, outer, inner, last. And when you did the last, a 12 popped out. So that means that 12 has to equal whatever this times that is. What are my possibilities for 12? 12 equals what times what?
1 times 12.
Times 12.
6. 2 times 6.
2 times 6.
3 times 4.
3 times 4. Then I think that's it, right? I don't think we can do it any other way other than like 4 times 3, which may be what we have to do here. Because you'll notice if you put a 3 here and a 4 here, you're not going to get the same thing as if you put a 4 here and a 3 here. So now, okay, we have possibilities for L. So we're going to just basically, this leads us now to part A. We found possible ones. We found the possible combinations, and now we're going to try them. Okay, now one thing I know, so one thing to notice here is like with 1 and 12, I could just go ahead and see that it probably wouldn't be wise to try 12 and 1 like this. Why? Because, well, this all comes down to finding out what this is, right? When we FOIL, that middle term comes from the outer and the inner multiplications. And I could see that if I had a 1 here, then the outer would be a 2x times a 1. The inner would be 12 times 5x, and 12 and 5 is 60x. And I could see that way overshoots the 23, right? So I'm not going to try it that way. I can also see, like, if I did a 12 over here and a 1 right here, I guess I'd have 24 and 5, right? I'd have my outer would give me a 24x and a 5x. And that, since the 24 already overshot that, it doesn't look too good. So that's not going to work. What about 2 and 6? So here, let's just try 2 and 6. So if I put a 2 here and a 6 here, what is my outer going to be when I'm going to do my outer multiplication?
12.
12x. And what's my inner multiplication?
10.
10x, 12 and 10, almost, not quite, right? If I add them together, that's not going to give me 23. So maybe switch them around. How about a 6 and a 2? Now, a lot of this, I'm writing it down, but the more of these that you do, and this is why you're going to have about 25 of these to do tonight, is you start to just, you don't need to write every single one of these down, right? You'll get to a point where you could just try it in your head. But this is what I'm doing. We have the outer would be, I guess, a 4x. The inner would be a 6 times 5 is 30x. That's already too big. That's not going to work. If I tried the 30 minus 4, that would give me 26x, and that's not going to work. So, nope. Looks like 3 and 4. So let's try the 3 here, the 4 here. What do I get from my outer multiplication?
8.
8x, and then my inner?
15.
15x. Can I combine those to give me 23?
Yes.
Yeah, with a plus and a plus. Okay, so what we've been doing, I didn't write this. Didn't write this out as a step, but it's, I guess that part B is really part 5, which is do O and I do the outer inner multiplications. I guess that's all part 5. Sorry about this. So do outer and inner multiplications, combining and changing signs as necessary, and do the outer and inner with signs. I think the last time I wrote this up, I said do the signs last, which is indeed the last thing that we're doing, right? We're trying to figure out, okay, if that one's a plus and that one's a plus, then it does combine to give me a 23x. And so, yes, that means I want a 3 here. And so this is actually the way I do it. I write little numbers beneath what I want, and then once I find the ones that work, I'll write it finally like this. And then the way I like to do it is I say, well, if that one needs to be a 15x, that one needs to be a positive 15. I know that that came from the middle one, right? That came from my inner multiplication, which means that that number right there needs to be positive. Again, now I look here at this sign and say, well, that came from my outer multiplication. So that means that the number with the outer multiplication, that is this guy, needs to be positive. And so right there. Last step, as always, check your work. So we're going to go ahead and check this guy. I'm going to say, okay. In fact, I'm not going to do it. You're going to do it. What do I get when I do first?
10x.
10 what?
Squared.
Outer?
1. 8x.
Is it plus or minus?
Plus.
Okay, plus 8x. What about my inner?
Plus 15x.
Plus 15x. And what about my last?
Plus 12.
And I could see that, yep, those combine to give me 23x, which is exactly what we started with. Check, and we are done. Now, you can see, like, this gets a bit tedious when you don't just have a plain old x squared by itself, because you have to guess, well, was it 10 and 1? Or is it a 2 and a 5? Like, and the more factors that this guy has, the harder it's going to be. But none of the ones in your homework, or certainly none of the ones I'm going to give you, are going to be too bad. I'm not going to give you like 144, which has 1,000 divides, like, so usually you have a choice between 2, maybe 3 ways of writing it, and not that bad. But this is the way I always do it. Some teachers I have seen, they have this, and Mika and I were talking about this. They have, I'm not sure if you've ever seen it. They have like a square and squares and squares, and then you put some terms in different things. I don't know how to do it, but it confuses the hell out of me. And this is how I think about it. It's basically, we're unfoiling. I like having this step 2 right here, because it reminds me of the fact that this came from 2 things. And how did we get those? Well, you must have gone first, outer, inner, last. And so the first multiplication must give you this. So there's only 2 possibilities. It's either 2x and 5x, or it's a 10x and a 1x. And so, again, with the end and stuff like that, this is how I like to do it. This is how I'm going to recommend to do it. Any questions on this? Or are we ready to just start knocking a bunch of these out?
Yeah.
Okay. So let's do. Yeah, we did a difference of squares. Let's do this guy, 50. Okay. So this is number 50. and it is 4t squared plus 4t minus 15. Okay, so walk me through it. What's the first thing I want to do?
Look for a common factor or variable.
Yeah, is there any common factor there?
No.
No, that's a 3 and a 5. That's a 2 and a 2, 2 and a 2. And we have the descending powers of t. There's no way of pulling anything common out. Okay, so what's step number 2?
Right, the parentheses.
Parentheses. Okay, now, what do you want to put in for f? There's a couple possibilities.
Either 4 times 1 or 2 times 2.
Which one do you want to try first?
2 times 2.
Okay, so we're going to do 2. So what do I want to write here?
2t.
2t. Nice. And then what about here?
2t.
2t again. All right. So that's my candidate for f. And it might be, we don't know yet, but we might get all the way down to here and then find that every single thing we have tried has not worked. And we have to go all the way back and change this to a 4 and a 1. Sometimes that happens, and that's tough. Sorry, that's life. So this is honestly what I would try first. I usually go with the smaller of the numbers. Just like last time we had, it could have been a 10 and a 1, or it could have been a 2 and a 5. My intuition tells me try the smaller numbers first, 2 and 5. It also makes for easier calculations, right? So
Yeah.
2, I like it. So what we have found f. Now we need to find L. What are my possibilities for the last multiplication?
3 times 5 or 15 times 1.
15 times 1. Which one do you want to try first?
Yes, 3 times 5.
Let's try 3 and 5. So now here's an interesting thing. Since this is a 2 and a 2, it doesn't matter if we put the 3 here or the 5 here, or the 3 here or the 5 here, we're going to end up getting the same thing. If we had a 4 and a 1, then we would need to check both ways when we're doing our 3 and our 5, unless we just happen to be lucky and found the correct one first. But so in this case, it's not going to matter which order I put it. So I'm going to go ahead and go, okay, a 3 here and a 5 here. Okay, so now let's do the outer and the inner. What do I get from the outer?
10t.
And the inner?
6t.
6t. Is there a way of combining those to give me 4t?
No. Yes. You subtract.
Yeah. So what's positive and what's negative?
Sorry.
Yeah. No, I just no idea how many times I've done this. Like, right? Nope. That doesn't make 4. There's no way. Moving on. And then you're down to like you've done every combination of all of these. Like, and you're like, okay, well, let's go back. Maybe it's a 4 and a 1. None of these are working. So okay. So which one's positive and which one's negative?
Well, 5 is negative. Wait.
Whoa, I'm just talking about these right here.
Oh, 6 is negative.
6 is negative. 10 is positive. So that means, and so now I've found it. I'm going to go ahead and say, yes, these two are the ones I want. So I'm going to write my 3 here. I'm going to write my 5 there. Now, which one gets the positive? Say again.
Hold on. The 3.
Let's see. So you say the
No,
three-
wait, the 3 gets the negative. That's what I meant. The 3 gets the negative and the 5 gets the
three gets
positive.
negative, yes. Because now remember, at this point, and this isn't just like, we have to keep in sight. We want to keep what we're doing in our mind, and that's the outer inner multiplications, right? And so if you ended up with a -6, well, where did the 6 come from? There's only two possibilities. It either came from this multiplication or it came from this multiplication. And so I know, and you already said it, that the negative had to be in front of the 3 because we need to have the -6t, and then this will give me the positive 10t right there. And so as far as I'm concerned, step 5 is done. I believe that this should work. So finally, we're just going to go through and check it. So first gives me what?
4t squared.
Good. Outer gives me?
10t.
Inner gives me?
-6t.
And last gives me?
-15.
-15. So let's see, 4t squared, 10 minus 6 is plus 4t minus 15 is what we started with. Check. We have factored this guy. We are done. Now, one thing to notice, and one thing that you could tell right away, is that there's a negative sign right here. That had to come from the L multiplication, the last multiplication, when we multiplied this guy and this guy. If that's a negative number, then they have to have opposite signs. Either that one's a plus, that one's a minus, or this one's a plus, that one's a minus. And so it's just as you're moving along, right? Like let's say that we had some candidate for 2t and 2t, and we had something that's supposed to combine to give you a 4t. And perhaps now this, of course, is not going to work because this isn't our problem, but let's say that our candidate was like 1 and 1. And we said, okay, the outer would be a 2t, the inner would be a 2t, and the only way to get a 4 out of that would be a plus and a plus. And so it must be +1 and +1. And then we could say, well, wait a minute, that's a negative number. Of course, I know it doesn't work out. 1 times 1 is not 15. But you see what I'm saying, right? Is like, you get to this point and you go, well, the only way to get what we want is with a plus and a plus. And that has to be a negative number. Uh-oh, one of those has to be negative. Then my candidates did not work. It must be wrong all the way back. Or, those two candidates must have been wrong. I got to start over. That's going to happen about 10 times, I guarantee you, that you're going to go, oh, that'll work. And then you say, oh, wait. And if you don't notice that, like you'll go and FOIL it all out and go, wait, why didn't that work? Well, that could happen. So, yeah, do we have time to do one more? We have time to do one more. Let's do one more. So, that one's too easy. That one looks hard, but oh, that's a homework one. Let's do that one. That one looks terrible. So, x squared. All right. Oh, which one was this? 60. 18x squared minus 6x. Now, if you're looking in your book, this is written as 18x squared minus 24 minus 6x. And they love to do this. They love to give it to you like that. And then you say, wait a second, hold up. Yeah, I'm going to rewrite this. I'm going to say, why don't we write it like this? Right. Because that's going to make my life a lot easier. So this guy right here. Woo! Okay, are there any common factors?
Yes.
Okay.
No, wait. Yes.
What do you want to pull out first? Because we don't have to do this all at once. We could do it one number at a time if you want.
Hold on. Can we just start with the 2?
Yeah, exactly. Like, again, I said this last time, like the book makes it sound like you have to know exactly what the thing is to pull out. It's like, well, I noticed those are all even. Why don't I just pull out a 2? So let's do that. I'm going to, and this is how I like to write it, I'm going to pull out the 2. What's left right here?
9x squared.
9x squared. What's left right here?
Minus 3x.
Minus 3x. And what's left right here?
12.
Minus 12. And then I double check and say, okay, if I multiply the 2 through, I'd have an 18, a -6, and a -24. Okay, I'm good to go. Is there a common factor?
3.
Yeah, so let's pull the 3 out. So the way I'm going to do this, I'm going to go ahead and skip this step and say, when I pull the 3 out, the 3 hits the 2 and becomes a 6. What I've really done here is I've just said, well, there's a 2 out front. And now I pull out an additional 3. It's 2 times 3. That is 6. Okay, so I pulled out a 3. And what actually, let's just do that. Do it this way. 2 times 3, because this helps me visually. Now I can say, yeah, you just pulled out a 3. So what should this guy be?
3x squared.
3x squared. Good. And what about this one?
Minus x.
Minus x. And this one?
Minus 4.
Minus 4. And now I'm going to double check and say if I took this 3 and plugged them back in, we would have a 9x minus 3. And then a minus 12. Good. And that guy would be gone. And we'd be left with our 2. Okay, that looks good. Is there anything else we could pull out?
What did you say?
Is there anything else? Any other common factors we could pull out?
No.
No, we're done. There's a 3 and a 4. Those have nothing in common. There's a 1. Looks like we're done. So what's my next step?
The parentheses.
Right, the parentheses. Now, here's another hint, big hint I'm going to give you, or advice. We're going to call this advice. Is as we're doing this, you'll notice that everything that I wrote, I have not changed anything. Like this is exactly equal to this. This is exactly equal to this. This is exactly equal to this. And so what I did here is when I dropped down to say, well, this thing can be written as this, I did not forget that 6. Like, yes, I know that right now we're going to focus our efforts on this guy. And we might want to lose sight of the bigger picture. But I can't tell you how many times I've had students who do something like this and then they give their answer as without the 6. And it's like, well, why'd you lose the 6? Why'd you drop the 6? And they look back and go, oh, I don't know. So like, it's easy to lose sight of the bigger picture. So just get in the habit of every time you copy something down. And in fact, what I do often is I just put equals signs for every single one. That way it reminds me like, yeah, I'm not like starting a new problem here. Like there's this larger context. This has to be there. So, okay, that's my little tirade. Sorry. So what do we write for F? What is here and here?
3x.
And what?
Oh, 3x. No, x.
Just x. Good, good, right? And so the idea here is that's a prime number, right? You can't break it down anymore. It's got to go with one or the other. Another thing I know is since that's the first multiplication, we have to get an x squared out of it. There's really only one way of doing it, right?
Right.
Had it been something like we'd seen before, like with a 6x squared, well, then we have some possibilities. It could be 2x and a 3x, or it could have been an X and a 6X or whatever. But in this case, there's only one way of doing it. You have to have a 3X, you have to have an X. That's the only way.
Come back and get you.
So it looks like we won't have to come back and try different F. We're lucky, like it's nice. So now, L, what are my possibilities for L?
So please go get in the truck right now.
2 and 2 or 1 and 4.
2 and 2 or 1 and 4. Which one do you want to try first?
Well, let's do 1 and 4.
Okay. Do you want the 1 here and the 4 here? Or you want it the other way? Doesn't matter. I mean, we can try.
Yeah, let's do that.
Okay. So outside multiplication gives me what?
12
12x, and the inside gives me what?
x.
X. Is there a way to combine those to give me -1?
No.
No. Okay. So what do you want to try next?
I guess you could swap them.
Swap them. Yes, that's usually the way I do it. I try it one way and then I'll swap it. So instead of a 1 and a 4, we'll go a 4 and a 1. Outside multiplication gives me what?
3x.
And then the inside gives me what?
4x.
Is there a way of getting those to give me a -1x?
Yes.
How?
Subtract 4x from 3x.
There we go. So we need a plus 3x minus 4x, and it should give me a -1x. And so I believe that 4 and 1 will work. I'm going to go ahead and write them in here. 4 and 1. Now let's figure the signs. Who gets the plus and who gets the minus?
The 4 gets the minus.
4 gets the minus, and then the 1 gets the plus. Right? So, okay, it looks like we're done. Let's check it. So, what I'm going to do is leave that 6 out. We're not going to worry about the 6 just yet. So let's just go ahead and do it. First gives me what?
3x squared.
Yep. Outside gives me what?
3x.
Plus 3x. Inside gives me what?
Minus 4x.
And the last gives me what?
Minus 4.
Minus 4. And I can see that that's going to give me 6 times 3x squared minus x, which is what we needed. Finally, minus 4. And if I were so inclined, I could go ahead and multiply the 6 in, which I'm just going to look and go, okay, 6 times 3 gives me 18x squared minus 6x, which is what we had there. Finally, 6 and the minus 4 gives me minus 24. And so I am good. One last thing that I didn't mention is because we're working with it actually being squared. And I don't think, you're not going to see anything until later. Actually, nope, you are going to see it. Oh, we need to talk about that. Sorry. We got to talk about one more thing. But these can't be factored anymore. Now, it might be that that's because, this is just one x right there. That's just one x right there. And so we can't break that down anymore. That's all the way factored. And so that's our final answer right there. But it could be the case that we're not done. How might something like that happen? Well, and I'll just do this real quick. You'll see this in your homework. But let's say that our original problem, instead of being this guy as given, something like this. Now, if you were just given that right there, you would say, wait a minute, whoa, 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 I don't know how to factor things to the fourth power. We haven't talked about that. What you'll notice is this is almost the same kind of thing we've been working with. This is something to an even power. This is half of that power, and this is that to the 0th power. And what I would do in this situation is say, well, wait a second. Remember, math is the game where we turn things we haven't seen before into things we've seen before. And so what I would say, well, you know what? If this were an x, if that were just a plain old x, then that would make my life easier. And so what I'm going to do is I'm going to say, well, let y squared equal x. And if that's the case, then when I square x, x squared, that's the same thing as y squared squared. Y squared squared is y times y times y times y. That's just y to the 4th power. And now, oh, hey, look at that. I could turn a problem I haven't seen before into a problem I've seen before. I could say, well, everywhere that I see a y squared, I'm going to write an x. So we have minus 6x minus 24. And then instead of the y to the 4th, I could write that as x squared. And say, oh, 18x squared. And then from there, I would do exactly what we did, and we would find that we have 6. It was 3x and an x, and I believe it was a 4 and a 1. Yeah, a 4 and a 1. And then we had the minus went with the 4 and the plus went with the 1. Yeah, so that's what we did, right? So we took a problem we hadn't seen before, turned it into a problem we've seen before, then we end up here, but then we got to remember, whoa, wait a minute. That original problem had nothing to do with x's. The original problem had something to do with y's. Luckily, since I'm me and I wrote it down on my paper like I always do, I could go, oh, hey, x is actually equal to y squared. And so I'm going to plug in everywhere I see an x, I'm going to plug in a y squared. Oops. There. Y squared minus 4. And then y squared plus 1. There. Now, finally, I'm going to check. And so I get my 6. And so 3y squared times y squared is 3y to the 4th. The outer gives me a plus 3y squared. The inner gives me a minus 4y squared. The last gives me a negative 4. And I have 6, 3y to the 4th minus y squared minus 4. And then I distribute that guy in and get 18y to the 4th minus 6y squared minus 24. And I can see that, yes, that is the same thing as that. And so we're good. And I would say that's my answer right there. Things in this form where you have some number times x squared minus some number times x, or plus or minus some number times x with another number, we call those quadratic equations. And sometimes you could turn an equation that's not quadratic into a quadratic equation. This is going to be a major theme later on in our class. And so this is just something you could do. It doesn't just have to be y to the 4th. It could be any even power, or even it could be, for instance, if, am I good to erase this? Were you following all this?
Yes.
So, for instance, if we had the same thing, but instead of, let's take any number. How about z to the, I don't know, 17th? Well, double 17 is what? What's 17 times 2? 34. 34. 34. Z to the 34. that is a quadratic in disguise. It doesn't look like it. And when I look at that, I go, oh man, I can't do that. But then I say, wait a second. This thing right here is 1/2 the power of that thing. So I could do my same little trick and say, well, okay, then if this thing right there were an x, just an x by itself, and I'd say, okay, if z to the 17 were just an x, then that would make my life a lot easier. And I'd be turning this into a problem I've seen before. I just got to hope that when I square x, I get that. So let's see. X squared would then be what I just had squared. In other words, z to the 17th squared. Z to the 17th times z to the 17th is, well, you have 17 z's here, you have 17 z's here, you have a total of 17 plus 17 is 4 and 3, 34. Yep, that's the same thing as z to the 34th is x squared. Oh, hello. And so I plug that guy in and say, okay, then x squared minus 6x minus 24. Do the same thing. We end up where we were, but then in the end, I would be plugging in this guy for x. Does that make sense?
Yes.
Okay, so that is about it. You have homework, and okay, yeah, ready for homework?
Yes.
Okay. Any last questions with any of this stuff?
I don't think so.
Okay, cool. So, homework. I believe this is homework 8, and it is chapter 5, section 5. Section 5. Don't freak out. Don't freak out. Don't freak out. 1 through 87, every other odd. Okay. So that breaks down a lot. That's like 24 questions. Okay. It's
Okay.
1, not 3. So what you could do is just think about this: 7, 9, 11, and go every other odd. So you're not doing 3, you're not doing 5, you're not doing 11, and so on. Now, a nifty formula for this, if you want a nifty formula, it's actually 4n plus 1, where n is equal to 0, 1, 2, and so on. And you kind of see, like, yeah, plug in a 0, you get a 1. Plug in a 1, you get a 5. Plug in a 2, you get 8 plus 1 is 9. Plug in a 3, you get 12 plus 1 is 13. Oh, nifty formula. So you might like that. And so, okay, then there's a couple more there. That's 87. And then I just wanted you to do that one and that one. So 91 and 90. So it's like 26 problems, I think, total. So